Here we are looking at example 8 from our 2.4 number 1 set of notes. We're asked to write the equation of a line with this x-intercept 4 and y-intercept of 5. So really fast, just graphically. Here is our xy plane. Now let's assume that we have this x-intercept being at 4. Notice, in fact, because it's an x-intercept, it's literally crossing your x-axis at 4. So we have 1, 2, 3, 4. Well, if you're crossing this x-axis, your y value is not going up or down any. And as a result, we would end up with this point here at 4, 0. Likewise, with your y-intercept happening at 5, it's crossing this y-axis specifically at this point. It's crossing this y-axis specifically at 0, 5. In other words, for our x value, we're not moving left or right any. And that's why our x value is 0. Again, because it's crossing this y-axis. Now, between any 2 points, we can go ahead and find the slope of those 2 points. And again, slope is just y2 minus y1 over x2 minus x1. We can just say that this is our x1, y1, and this will be our x2, y2. Again, order doesn't matter, just as long as your algebra is actually correct in the end. So y2 is 0 minus our y1, here is 5, all over our x2, 4, minus our x1, 0. So it looks like our slope comes out to be negative 5 over 4. And that even kind of just makes sense just from our graph. We can see our slope is negative, it's going downwards. Pretty bad line, but imagine that this is a straight line. Now, we have our slope, and that's great, but we're trying to go ahead and write the equation of the line that satisfies this condition where it's passing through those 2 points with this slope. Well, again, if you recall back to point slope, we have y minus y1 is equal to m times x minus x1. And we already have our slope that we're going to go ahead and use, but we're missing an x1 and y1. Well, in fact, we actually have 2 to choose from. We have this point here and this point here that we can go ahead and throw into the equation. I think just for ease, let's go ahead and use this 4, 0. And we'll talk about y in a second. They're pretty comparable, but again, it's not too bad. So let's go ahead and use 4, 0. End up then with y minus 0 is equal to our m times this arbitrary x. Oops, we already know what m is. We can throw him in there. That is negative 5/4 times this arbitrary x minus this x1. In this case, it's 4. Well, on the left side, when you're trying to solve for y, notice we're taking y. We're not subtracting anything from him. So he's literally just still y is equal to, distributing in this negative 5/4 to both items, we end up with negative 5/4 x. Negative times a negative is a positive. We end up with 5 times 4 is 20, divided by 4 comes out to be 5. So here is the equation of that line passing through those 2 intercepts. Again, it wasn't asking for standard form, so you could actually go ahead and leave it into y equals mx plus b form. And again, though, that is example 8 from our 2.4 number 1 set of notes.